Alright, in this video we are going to talk about finding vertical asymptotes of a rational function. These vertical asymptotes are coming from the zeros of the denominator that are not also zeros of the numerator. So what we're looking at first is the denominator of this function. You have f of x equals x plus 1 over 4 minus x. So this 4 minus x is what we are looking at. We're going to find its zero, which means set it equal to 0 and solve it for x, which means I would add the x to both sides to cancel out the minus x. So now I have 4 equals x. What this means is that this graph has a vertical asymptote at x equals 4. You are typing in that equation because here's what that means. A vertical asymptote is going to be this vertical line at x equals 4, where the graph will come right up against that vertical line, but not cross it or touch it. So that's why it's an equation, because it is a line that your rational function will not cross. Okay? Now, I also need to make sure that 4 is also a 0 of the numerator, because if we have x plus 1 and set it equal to 0, and then subtract 1 from both sides, we get x equals negative 1. What that tells me is that negative 1 is the 0 of the numerator, which is not the same thing as 4. So this is a true vertical asymptote. Right, we're going to do the same thing on this next problem. We've got f of x equals negative 2 over x plus 4 times x minus 2. So this one actually has 2 zeros in the denominator because it has 2 factors that I'll set equal to 0 and solve for x. So on the first one, I will subtract the 4 from both sides. So I get x equals negative 4. And on the next one, I will add the 2 to both sides. So I get x equals positive 2. Looking at the numerator doesn't have any zeros because it doesn't have any x's in it. So your 2 vertical asymptotes would be at x equals negative 4 and x equals 2. On this next example, my denominator is x squared plus 2x. If I'm finding the zeros of that denominator, I need to find the factors first. So looking at each of these 2 terms in my denominator, I notice that they each have an x in common. So I'm going to factor out an x and put in parentheses what is left. It's kind of like you're undistributing that x. So if I take an x out of that first term, I'm left with x plus, if I take an x out of that last term, I am just left with 2. So now I am in factored form, and I can set each of these factors equal to 0 and solve them for x. So this one's already solved because the x is by itself. On the other one, I will subtract the 2 from both sides to get x equals negative 2. Then I just need to make sure, remember that vertical asymptotes are zeros of the denominator, which ended up being 0 and negative 2, as long as they are not also zeros of the numerator. So I just need to double check that I don't have any zeros in common. If I set the numerator equal to 0 and solve it for x, I will get x equals 3. So that is neither one of the zeros of the denominator. So x equals 0 and x equals negative 2 are both vertical asymptotes. All right, in this example, I'm going to do the same thing. I'm going to find the zeros of the denominator first. Now, I notice that my denominator needs to be factored. I need to write it in factored form. So these first terms in each of the factors need to multiply to equal x squared. So when I do that, I get x times x. What goes at the end of each of the factors has to do two things. The first thing it has to do is multiply to equal negative 28, while at the same time adding to negative 3. So in order to do that, I will need a negative 7 and a positive 4. That multiplies to negative 28, and then negative 7 plus 4 gives me negative 3. So now that I have my factors, I can set the factors equal to 0 and solve them for x. So on the first one, I will add 7s. So I get x equals 7. And the other factor was x plus 4. So when I set it equal to 0 and solve it for x, I get x equals negative 4. So I just need to make sure that 7 or negative 4 is not also a 0 of the numerator. So I am going to write the numerator also in its factored form. So I will have x and x for x squared. Now remember, the last numbers have to multiply to negative 24 while adding to positive 2 in this case. And I will do that with a positive 6 and a negative 4. If I set these equal to 0 and solve them for x, I will get the zeros of the numerator. So I will subtract 6's from both sides of the first one, so I get x equals negative 6. And on the last one, I will add 4 to both sides, and I get x equals positive 4. So when I look at my zeros in the denominator, neither one of those are also zeros of the numerator, which means x equals 7 and x equals negative 4 are both true vertical asymptotes. All right, last example. G of x equals x to the third over 4x cubed minus x squared minus 18x. So I am looking for zeros of the denominator. What I notice first is that all three terms have an x in common. So I'm going to pull out an x and put in parentheses what is left. So they are each just going to lose an x. So I will have 4x squared minus x minus 18. So the x is one of the factors. It's completely factored. Also, I need to find the zeros of this. This shortcut means I can put that a, b, and c into my quad calculator. So a would be 4, b would be negative 1, and c would be negative 18. So again, you are putting that in the quad calculator link and seeing what you get as the other two zeros. So when I put that in my quad calculator, it gave me 9/4 and negative 2 as the zeros that came out of the quad. So that's 9/4 and negative 2. And when I set that one equal to 0, it just gives me 0. So I have three zeros of the denominator: 0, 9/4, and negative 2. Now look at your numerator. what number, when you plug it in for that x and raise it to the third power, gives you 0? Well, that number would be 0. So what we see on this example is that there's a 0 in the denominator that is also a 0 of the numerator, which means it's not a vertical asymptote, which means your only vertical asymptotes are x equals 9/4 and x equals -2.